I'm Rasoul Akhavan Mahdavi. I'm a PhD student at the University of Waterloo. I'm working on applied cryptography. So I first heard about FHE at the end of my undergrad as part of an internship where we were working on a submission to the iDash competition. And when you first hear about FHE, usually the first thing you think is, how is that possible? And then immediately you think that this sounds magical. One specific one I'm fond of because of its simplicity and because I like uh, learning how things work under the hood is is a less known scheme called FH over integers, which was introduced after Gentry's initial construction, which was really hard to understand. And FH over integers was really easy to understand. It helped you actually understand how bootstrapping works. So just for the case of simplicity, I am fond of that scheme, but it's not something anyone would actually use. So it's a different type of interest. I'm very fond of just working on math, but I also like programming and coding and building small things, prototypes and such. And generally, cryptography seemed like an interesting area that had the best combination of both programming and coding while also having a lot of math under the hood. And FHE is kind of an example of that. And the difference being that with FHE, you can do a lot of things instead of just being confined to a simple thing, a simple task, whereas FHE gives you a lot of options to build lots of great tools and just interesting stuff. The typical challenge is that it was a relatively new field, like not super new, but when I was getting deep into this field, it was relatively new and evolving. And it's fun because you get to see things change so quickly, but you also get to see things change so quickly. And you have to adapt to the math changing, the algorithms changing, the libraries changing, and it keeps you on your toes. But it's a challenge, but it was also very fun to see the constant change in the literature. Well, hopefully we'll go to the point where it's less and less noticed because it will be so well built and so easily accessible that anyone can use it without having to deal with the peculiar details of setting parameters and like all the finicky details that come with working with FHE. So hopefully more people will know about it, but less people will need to know all the details that happen under the hood. So that will help a lot of people just build stuff using FHE without needing as much expertise as all of the cryptographers have. The big thing that is consistent across all FHE schemes is the fact that they have very large ciphertext. So dealing with these huge objects makes it hard and makes it hard to work with, and is an interesting research question as well. Because speed has always been an issue, and everyone has been working on that for a long time. But the size of FHE ciphertext is something that is less noticed, but it's a big problem. So I would love to see some research breakthroughs in fixing that. My advice is just find your place in the stack. Don't think that it's only math or it's only something else, because of the because of how big the stack is from all the way from hardware all the way up to the schemes and algorithms, you can work on any part of the stack that you're interested in. So don't think you have to stick to some specific part like the algorithmic part or the scheme level or the compiler level. No, there's literally room for anyone with any sort of interest in the FHE community. Just find the people that are also working on the things that you're interested in within the community.